Hello. 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 Yeah. और तुम थोड़ा देर से फोन करो मैं क्लास चल रहा है। Okay. Hello everyone. Okay. So, do you know my name? All of you. Hello. Can you hear my voice or not?
Yes, sir.
Okay. 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 I think we can start the class, na? Hello. Okay. So I will take your subject structural analysis. Okay. So if you can't hear my voice properly, you can write in the chat box or you can directly tell me. Okay. You can unmute and you can say whether you can hear me or not. Okay. Hello. I hope all of you can hear.
Okay, sir.
Okay. 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 So in this subject, basically, we will mainly we will discuss about the RCC structures. Okay. RCC means reinforced cement concrete structure. Okay. So first of all, do you know what is concrete? Hello. Do you know what is concrete? Please speak up. You unmute yourself and tell me the answer. If you don't know, just tell me don't know, or if you know, just tell me at least something. You say something. Hello. Do you know what is concrete?
Yes, sir.
Yeah, you tell me then. What is concrete?
Sand and what?
Huh? I can't.
Mixture of water, sand,
Sir, concrete is a paste of cement, sand, and water.
Cement, sand, and water. No, it's not concrete. Do you know anyone? Anyone? Just tell me what is concrete.
A mixture of cement, fine aggregates, coarse aggregates, water.
Okay. 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 So, do you know the different grades of concrete? Do you know the different grades of concrete?
No, sir.
No, sir.
Yes. You tell me some grades of concrete. if you hear me, please tell me, okay? Otherwise you are wasting your time only. I am asking a question, you are waiting for 2-3 minutes, then someone answering. At least if you can hear my question, please speak up, at least someone. And yeah,
M20, M30, M25.
okay. Okay, so did you hear the term RCC? You heard the term RCC, means reinforced cement concrete. I can't hear anything. Raju, I can't hear anything.
Great.
So reinforcement cement concrete.
Okay, so what is the meaning of that reinforced cement concrete?
Reinforcing steel bars in concrete, sir,
Okay, why it is done?
to increase the tensile strength.
To increase the tensile strength. Hello.
Yes, sir.
Okay, so why it is used?
The concrete alone is weak in the compression strength, so steel bars are used for the
And
tensile strength compression.
Okay, is there any other reason? Is there any other reason except that? Is there any other reason of using steel in concrete except increasing the
provide
tensile strength?
strength in extra.
The compressive stresses also.
Compressive stress also? No, no. One. If anyone can give another reason for using steel, okay, you will get 2 marks bonus in sessional. Anyone?
Provide two good strengths in the
No,
structure.
no, 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 no. You just don't give me some general answer just to increase strength and all. No, I want the specific reason. One reason is to increase the tensile strength, which already I got the answer. But I want the second reason of using steel in concrete. Okay, so you answer within 1 minute so that you will get 2 marks sessional extra 2 marks sessional. You can tell me or you can write down your answer in chat box also.
It can help a building survive an earthquake.
Yeah, see again you are saying some general answer. I don't want to hear those general answer, means to increase the strength, to provide the stability and all. No, not for that. Specific answer. Please write down your reasons. Your reason might be correct. You have 1 minute. I will give you 2 marks extra sessional. Sessional mark. Okay, okay. I hope no one knows the no other reason. Okay. Okay, the second reason is, can you hear me? Hello? Okay, the second most important, concrete and steel both have same coefficient of expansion and contraction. That means at the same temperature, both concrete and steel contracts and expands at same rate, almost same rate. That is another most important reason for using steel in concrete. Okay. So because of two reasons we use steel in concrete. One is to increase the tensile strength of concrete, and the second is since the coefficient of thermal expansion for both concrete and steel are almost same, because of that we use steel in concrete. Okay, so these are the two main reasons. Okay, and this is one of the most important questions which you will be asked in Viva. Okay, if you appear any Viva after passing out from this university, if you appear any Viva, then they will ask this question, or when you will appear in industrial Viva, I think in this semester only. At the end of this semester, you will appear one industrial Viva. Okay, so in that Viva, external sir will ask you one question, that why steel is used in RCC. Okay, so you have to tell both the reasons. First reason everyone knows. Everyone will say the first reason. Okay, and if you can say the second reason also, then only you will get good marks. Okay. Okay, so now I hope all of you. Okay. So now I will share the screen. Okay, you just tell me whether you can see the screen or not. Okay. Now I am trying to share my screen. Okay. So can you see the screen?
Yes, sir.
Okay. Okay. So now you see this is your syllabus. Okay. This is the syllabus. So I am not going through the first two chapters because these are all theoretical part, and you can see these things in internet also. Okay, for exam purpose also you will not get much questions from these two chapters. You will either, you might get one or two questions. Okay, 1 mark questions, only one or two questions you will get from the first two chapters. Okay, these are all basically theoretical part. Means what is a structural engineer, role of engineer, what is architect, what is builder, these things. I'm not going to this theory part. Okay, hello.
Okay, sir.
Okay. So I will share you the syllabus after the class. Okay. In your WhatsApp group, I will share the syllabus. You can distribute among all the students. Okay. So the first two chapters I am not going through because these are only theoretical parts. But I will start from chapter 3, chapter 4, and chapter 5 because in these chapters only we have numericals and we have a huge syllabus to cover. Okay. I hope all of you can hear me. Hello? Okay. Okay. So I assume that you can hear my voice. At least you can hear my voice. With the screen, I hope you can hear my voice also. Okay, so in this subject, we will design the various components. Okay, that means we will design. Hello. Okay, so in this subject, we will design the various components of a reinforced cement concrete structure. That means if you are considering a building, then we will design the slabs, we will design the beams, we will design the columns, and also if we have time, we will design the footing. That means foundation. Okay, and then we will go for the analysis of truss. Then we will see the suspension bridge. Okay, so we have a huge syllabus to cover. So I request you all to be present in all the remaining classes. Okay, so that at least we can finish the syllabus. Okay, and for this subject, all of you must buy at least one book. Okay, hello. Okay, so I will give you the names of. Okay, so I will give you the names of. Okay, so now I am writing. Okay, so now I am writing. Design. I hope all of you can see the chat box. See the chat box. I have
Yes,
written
sir.
down the names of the books. Design of RCC structures by S.S. Bhavikatti or Ramamrutham or Nilam Singh. You purchase at least one book. I have given you 3 books, but all of you at least purchase one book. In Ramamrutham, you will get lot of examples. Okay, lot of solved examples and exercise also you will get. Nilam Singh is a small book, but that one also you can buy. And S.S. Bhavikatti is also a very good book. Okay, so I request everyone, please buy at least one book for this semester. Okay, because you can come to university, so if you have a book with you, so it will help you a lot. Okay, you can take the book as a reference. So if you have a book, you will find it very easy. Okay, so hello.
Yes, sir.
Okay, so now
Hello.
you do one thing. Okay, you do one thing. All of you, please write your name as well as your enrollment number. Okay, in one comment, not separately. In one comment, you write down your name as well as enrollment number. Hmm. Mute yourself. Mute yourself. Karka. Karka. Okay, so 35, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so I got the attendance. Okay, I got the attendance. Okay, so now all of you have to buy what I am saying, that all of you have to buy at least one book, which I have written here. At least one book all of you have to purchase, and also you have to download this IS code. Means the one design code you have to download. This one IS 456 2000. Hello. You can see the chat box. I have written the design code. Okay. In Google, if you search this IS 456 2000, then you will get the PDF. You download the PDF, and this is the design code which we have to use while designing any building. Okay, while designing any building in India. Okay, so we will use this IS code throughout this semester. And in our next class also, we are going to use this IS code. So I request you all, after today's class, you download this PDF, means this design code, and keep it with you for the next class. When I will start the next class, along with the class, you just open the PDF. Okay, and we will going to use this PDF in our next class. Okay, so here in this semester, we have to study the various properties of steel and concrete. Okay, hello, yeah, save it on Ninu. Do you want to ask me something?
No, sir, by mistake.
Okay, it's okay. Okay, so I hope all of you can hear my voice. Is it?
Yes, sir.
Oh, yeah. Okay. So in this semester, first we have to study. Okay, so now I will share this. Hello. Okay, now I will share the screen. Okay.
Okay, now I will share the screen. Okay.
Can you see the screen?
Yes, sir.
Okay, so what you can see, what is this? What is this?
This
Huh?
Free body diagram.
Free body diagram. Free body diagram of what? Free body diagram of what?
Free body diagram of a beam.
What is the name of the beam? I am asking you, what is the name of the beam?
क्या क्या हुआ
Very supportive beam.
Yeah, this is a simply supported beam. So when I ask you some question, you give me a very specific answer. You are saying it is a free body diagram. Then I am asking you again.
तंदा
You are saying this is a beam. Okay. So when you answer specific. Okay, it is not okay. So now what is the second figure? What is this figure? Where NA is written? What is this figure? लिखा अनिया लिखा अनिया
yes sir
हाँ बोलो सेकंड फिगर जो नीचे जो है वो क्या है
सर क्लियर नहीं है सर
क्लियर नहीं है मतलब फिगर तो दिख रहा है ना
हाँ सर समझ में नहीं आ रहा सर
हाँ ओके सो कैन एनीवन टेल मी व्हाट इज द सेकंड फिगर
okay, so can anyone tell me what is the second figure?
Sagging of the simply supported beam.
sagging of the simply supported beam okay sagging okay so that means in our first figure we can see we have a simply supported beam okay and I have put some loads on this beam. Say this is your W1, say this is your W2, and this is your W3. That means in our first beam, this is a simply supported beam. Say I will write down the name also, AB. Okay. So on this beam, I have put three loads, W1, W2, and W3. Okay. So whenever you will give the load on a beam, then what will happen? Your beam will deflect. That means it will bend, is it? So our simply supported beam will bend like this, in this shape. Okay. So now this beam is made up of say PCC. PCC means plain cement concrete. this beam is made up of PCC, plain cement concrete.
This beam made up of PCC, plain cement concrete.
Okay, so now after putting the load, you can see your beam has been
Okay, so now after putting the load, you can see your beam has been.
Okay, so now what will happen in this
So now what will happen in
top layer?
this top layer?
What stresses are developed?
What stresses are developed? Can
in this top layer, what stresses are
in this top layer, what stresses are
Raju, can you tell me the answer?
Raju, can you tell me the answer?
This is the top, before putting the load, this was the top layer of the beam.
This is the top before
This is the bottom layer of the
load.
beam.
This was the top layer of the beam.
Okay,
This is
so
the
now
bottom layer
I
of the beam.
put 3 loads, W1, W2 and W.
Okay, now I put 3 loads, W1, W2 and W.
So after putting these 3 loads, your beam has reflected in
After
this
putting
shape.
these 3 loads, your beam has reflected in this shape.
So my question is, in this top layer, what kind
So my question is, in this top layer, what kind
can anyone tell me?
can anyone tell me?
Anyone?
Anyone?
Sir, compression stress.
Okay, good. And what about this?
Okay, good. And
What about this?
Tension.
Huh?
Tension.
Huh?
Yeah. In the and
Yeah.
this
In
dotted
the
line represent
and
what?
this
This
dotted
dotted line represent
line represent what? This dotted line represents
Neutral axis.
yes, neutral axis. So you can see above the neutral axis,
yes, neutral axis.
that means this portion. Above the neutral axis means this portion. Okay. So in this portion, what kind of stress will be developed? Compression or tension?
Compression.
Yes, compression. And below the neutral axis, that means this portion. Below the neutral axis means this portion. So below the neutral axis, what kind of stress will be developed?
Tension.
Huh? Below the neutral axis, what kind of stress will be developed?
Below the neutral axis, what kind of stress will be developed?
Sir,
Okay, so below the neutral axis, tension stresses will be developed. Okay, tensile stresses will be developed. So we know that our concrete is very strong in tension or compression. Concrete is very strong in tension or
It is very strong in tension.
Tension.
okay, compression. That means
Okay, compression. That means
this above portion, above the neutral axis, this portion
above portion,
is
above
safe
the neutral axis, this portion.
because we know that our concrete is very strong.
Because
Okay,
we know
so
that
we
our
can
concrete
take
is very
this
strong.
compressive stresses.
So we can
But
take
what will happen to this portion?
compressive stresses. What will happen to this portion?
What will happen to this portion?
What will happen to this portion?
Because in this portion, tensile will develop.
Because in
So what
this
will
portion,
happen to
tension
this
will
portion?
develop. So what will happen to this portion?
It will expand, sir.
It will expand.
Answer.
Up to how much it will expand?
Up to how much it will expand?
Okay, so below the you remember this one.
Okay, so
Axis,
below that you remember
since tensile stresses are developed, okay, and we know that our system is very weak in tension. Okay, so if we don't provide anything, then what will happen? You can see some cracks will be developed at the lowermost portion here along this line. In this surface, you will see some cracks will be developed. Okay, so can we allow those cracks to develop? Can we allow those cracks to develop? Yeah, if these cracks will be developed, then what will happen? Your beam will fail. So we must provide something which can take those tensile stresses. Okay. So we know that steel is a very good material. Okay, steel is a very good material and it is very good. It has a very high strength in tension as well as compression. So in which portion we will provide the steel? We will provide steel in this portion. We will provide steel below the neutral axis so that this steel can take all the tensile stresses. Okay. Okay. So if I ask you in simply supported beam, in which portion you will provide the main reinforcement, then what will be your answer? You will provide the main reinforcement. Then what will be your answer?
Below the neutral axis.
Yeah, you have to say below the neutral axis, not at the bottom. Yeah, you have to say below. Answer will be not at the bottom. We have to provide main reinforcement. There will be. We have to provide main reinforcement. Okay, so now I hope all of you understood this one. Okay, so now I hope all of you understood this one. I hope all of you have understood this case. I hope all of you have understood this case. Yes or no? Hello? Yes or no? Hello?
Yes, sir.
Okay, so now let us see. Hello? Okay, so now let us see. Hello? Okay, so let us see the case of. Okay, so let us see the case of. Let us see the case of cantilever. Let us see the case of cantilever. So this is our cantilever, okay? As you know that this is our cantilever, one side is fixed. As you know that one side is fixed. Your fixed end. Your fixed end. And this is this end is free. Okay, so when you put the load, how the cantilever will bend? How it will bend?
On the free end.
Yeah, it will bend like this. Your cantilever will bend like this. Okay, so now you tell me, in case of cantilever, which zone is your compression zone and which is your tensile zone? Above the neutral axis, this zone is called which zone, and below the neutral axis, this zone is called which zone? What zone? Above the neutral axis, this zone is called tension or compression.
Tension.
Okay, tension. This is your tension and this is your compression. That means in case of cantilever, you can see just the opposite of simply supported beam. That's it. In case of simply supported beam, our tension zone was below the neutral axis. But in case of cantilever, you can see our tensile zone is tension zone is above the neutral axis. Okay, so can you tell me, in case of cantilever, in which portion you have to provide the main reinforcement? Hello, can you tell me now, in case of cantilever, in which portion or in which zone you will provide the main reinforcement?
So above the neutral axis.
Yes, yes, above the neutral axis. Okay, so this is one of the most important question which will be asked in your interviews, that in case of cantilever, where you will provide the main reinforcement. Okay, so your answer must be in case of cantilever, to provide the main reinforcement above the neutral axis. Okay, hello. In case of cantilever, you have to provide main reinforcement above the neutral axis. But in case of simply supported beam, you have to provide your main reinforcement below the neutral axis. Okay, so is that clear, everyone? Can you understand what is the reason behind it? Hello? I hope all of you can understand at least this portion. Why we are providing main reinforcement above the neutral axis and why it is below the neutral axis. I hope all of you can understood by these two figures.
Yes, sir.
Okay, okay. Okay, and last one thing I will ask you, that in case while preparing a concrete, can you add any amount of water? Can you add any amount of water? Or there is some limit?
Yes, sir.
Based on what factor you,
There are some limit
yeah.
in the addition of
So
water.
based on what factor you can decide how much amount of water you have to add?
Yes.
Okay, I can see some of the students newly joined. Just recently they have joined. 4 students. No, 5 students. 117. You can write down your enrollment number in the chat box quickly. Okay, our meeting is going to end within 4 minutes. Those who have joined recently, just now some of the students have joined the meeting. So please write down your enrollment number immediately in the chat box. Okay, so in our next class, you keep the PDF, keep that PDF with you. Okay, we are going to use that PDF. IS 456 2000. This PDF, you all of you please download it, and in the next class we will use this PDF. Okay. Roll number 109, 110, 11, 109, 110, 111, 112, 113. I think all of you are absent. Then 115 and 116. 118, 119, 120, 121. All are absent. Okay, then 101. 101. 101 absent. Then roll number 98 and 99. 98, 99 absent, I think. 98, 99 absent. Okay, roll number 93. Roll number 93 absent. Then roll number 89 absent. Roll number 84, 85. 84, 85 absent. Then 79, 80. Roll number 79, 80. Then roll number 75. Then 64, 65. 64, 65 absent. Then roll number 58, 59, 60. 58, 59, 60. All are absent. Then roll number 54, 55, 56.
57, sir. 57.
Ah, what? 57 present. 57 present. I know that. I am asking 54, 55, 56. Then 52. Okay, then 69. Okay, so these are the absent. These are the absent students. Okay, so I hope all of you understood what I have explained today. And in our next class, you